Every time you send an email, or stream a show, or just browse the web, you're tapping into this system of, well, just mind-boggling complexity. It feels like magic, right? But it's not. So today we're going to pull back the curtain on the incredible engineering that makes it all possible and find out how computer networks actually work. It feels instantaneous, doesn't it? But in that tiny fraction of a second, a single click kicks off an absolutely incredible journey. We're going to follow one tiny piece of data, step by step, as it travels from your screen, out into this vast digital universe, and all the way back again.
Okay, so first things first. Before your data can go anywhere, your computer has to translate that click into a language that networks can actually understand. And that language is built on signals.
And really, this whole journey is only possible because of networks. The best way to think of them is as these digital highways that connect every single device. I mean, without this interconnected web of hardware, our data would just be stranded. It would have absolutely nowhere to go. This is the foundation for everything we do online.
Now this is where it gets really cool. Here we see the two fundamental languages of data. Your computer thinks in digital, these super clear, precise on or off signals. But to travel through the air as Wi-Fi, that same data has to be converted into a continuous analog wave. This constant translation from digital to analog and back again is a crucial step that's happening silently all around us all the time.
So the signal's journey doesn't just start out on the global internet. Nope. It begins much, much closer to home, on what we call your local area network, or LAN.
Your LAN is basically your personal digital neighborhood. It's what connects your laptop to your printer, your phone to your smart TV, all the devices within your house or your office. This is the first and absolutely crucial link in the chain.
So, how are all these devices organized? Well, most home networks use what's called a star topology. Just picture your Wi-Fi router sitting right in the center with all your devices connected to it like the points of a star. Every single piece of data you send goes to that central router first, which then acts like a switchboard operator, connecting you to exactly the right destination.
Okay, so our data has successfully navigated your local network. But to reach a website on the other side of the world, it needs to take a great leap, from the LAN to the WAN.
And this is the Wide Area Network, or WAN. If your land is your house, the WAN is the entire planet's road system. And the biggest, most famous WAN of them all is, you guessed it, the Internet itself. This is the moment your data leaves its local bubble and goes truly global.
This table really gives you a sense of the sheer scale we're talking about. We start with a LAN in your room, which might then connect to a MAN, that's a metropolitan area network, that could cover a whole city. And that connects to the WAN, the global network that links entire continents with everything from undersea fiber optic cables to satellites way up in orbit. So, with billions of devices all connected to this global network, how does your one little piece of data find its way without getting lost? It's not just chaos out there. It all works because of a very strict and honestly, a very clever set of rules.
These rules are called protocols, and for any two devices on the internet to understand each other, they have to agree to speak the same language. Protocols are that shared language, and they ensure that data sent from one computer can be perfectly understood by another, no matter where it is in the world.
The absolute backbone of the internet is a protocol called TCP/IP. The best way to think about it is like a highly efficient postal service. First, TCP chops your message up into small, numbered chunks called packets. Then, IP stamps each of those packets with the destination address and a return address. These packets can then travel independently, each taking different routes to find the fastest path. Then, at the destination, TCP puts them all back together again, perfectly, in the right order. It's an incredible system that allows for amazing speed and resilience.
Okay, last but not least, let's talk about the physical hardware that actually makes this all possible. These are the unsung heroes of the network, the physical devices that manage this entire complex journey from start to finish.
First up is the modem. Think of it as the border guard between your local network and the wider internet. Its entire job is translation. It converts your home's digital signals into a format that can travel over your provider's lines, and then it does the exact reverse for all the data that's coming in.
Next is the router, the master navigator. It looks at the address on each and every data packet and makes a split-second decision on the best and fastest route for it to take across that vast, interconnected web of networks we call the internet. It is constantly calculating the most efficient path in real time. And then, back inside your local area network, you have the switch.
Now, if the router is the global navigator, the switch is the local mail sorter. It's the thing that makes sure a document you send to your printer actually goes to the printer and not to your tablet or your game console. It's all about precision delivery right there at the local level.
So let's just recap that whole journey real quick. A click becomes a signal, it travels through your local LAN, gets translated by the modem, and is then launched onto the global WAN by the router. It's broken into packets that follow the rules of TCP/IP, navigating a global network of hardware all the way to its destination, where it's put back together perfectly, all in the blink of an eye.
You know, the real takeaway here is this. There is an invisible architecture of hardware and rules propping up our entire digital world. It's a quiet miracle of global cooperation and engineering, and it is constantly evolving. So, as this system gets faster and smarter, you really have to wonder, what will this next generation of connection make possible?